right, folks. Integral from guys, be with me right now. Integral from 0 to 1 of x squared plus 1 cubed dx. How are we going to do this?
Take out the ugly.
U stands for ugly. So since Miss Ben Willis is engaged, let's use you for the whole period, I guess. All right, so that's u, so I'm going to go du equals what? 2x dx. So recognize this. I start changing around. I got integral from 0 to 1. I've got x squared plus 1 cubed x dx, right? What do I need, sir?
2.
I need a 2. If I put a 2 inside, what do I have to put outside? 1/2 out in front. So now it's going to be the integral 1/2. Integral x squared plus 1 cubed 2x dx. We're ready to u it. Oops, so I lost my 0 to 1. We're ready to u it.
Yeah.
Then let's u it. 1/2. I'm going to leave this like this right now, even though there's some rules I'm breaking that we'll get to later. This becomes u to the what? U to the 4th power divided by 4 plus c. I got a 1/2 out in front from 0 to 1, right? Down a little farther, I get u to the 4th over 8 plus c from 0 to 1. Now it's bounded as a c matter.
No.
Not at all. So I'm going to plug in the 1. No, I'm not. That's not an x, is it? So I have to switch back to being an x. How do I do that? I got to put the u back. I got to replace the u with x, right?
Yeah, you just plug in the
So I go x squared plus 1 to the 4th over 8 from 0 to 1, right? Dropping the c because the c doesn't matter. Plug in a 1. 2, 4, 8, 16 eighths minus plug in a 0. 1/8. Is that right? 1/8. Check my work. I get 15 eighths. Got it? Let me cut a few steps out of the middle. Is it okay with you if I cut a couple steps out of the middle? Okay, so right here, I'm going to go ahead and move this. Oh, no, I'm not. Come on. Yeah, not going to work today. That's fun. Let's try this one more time. Huh. Let's try it now. Now the computer's in a mental breakdown right now. That's good. Good place for it to be. Come on. All right, screw it. All right. Here we go. Here we go. Move forward. Okay, so I look at this. Instead of going this way, what I'm going to do is I am going to do this next step correctly. Because although I changed this to you, change this to you, what did I not change to you? The 1 to the 0. I didn't change my bounds to you. Probably should do that. So instead, I'm going to go, now it's trying to grab everything. That's awesome. Okay. Now, instead, what I'm going to do at this very point here is I'm going to go, well, 1/2 bounds u to the 3rd du, that's the same. But when x is 0, what is u?
1.
U is 1. So put a 1 down here. When x is 1, what is u? 2. Put a 2 up here. Okay? All right. Then this becomes u to the 4th over 4 plus c. I got 1/2 out in front from 1 to 2. Now, we go back to x because we have to, right? Because that's what we started with. But everything in terms of u, and I just want a number when I'm done. So guess what I don't have to do anymore? I don't have to go back to x at all. Plug in the 2, plug in the 1. So this is u to the 4th over 8 from 1 to 2. This should be a u. Plug in a 2, I get 2, 4, 8, 16 eighths minus 1 8. I get 15 eighths. And I'm already done. Ooh, yeah. Since we switched it, we switched the u's. I just pretend like x never happened. I never go back. So I raised my power by 1, by the power I get. Simplified. Plug in my 2. To the u now. Because these are u's, right? I'm going to plug it in, plug it in. I'm going to explain, well, let's hear your question. Yes?
Can you just go over how you found bounds again?
Oh, okay, so I looked at this and I said, well, this is x, right? So I took this value of x and I plugged it in right here for u. When x is 0, what is u? 0 squared plus 1 is 1, right? So that makes the bottom 1. And then I did the same thing for another one. I said, well, when x is 1, I plugged in here. 1 squared is 1 plus 1 is 2. Put a 2 right here. And that's where those two came from. Now I'm done with x. Now some philosophical calculus. Right? Philosophical calculus. The u substitution method, the switching your bounds to u is better. The reason why is because, remember, sometimes we end up with problems that are not integratable. How do we know that? Well, if we integrate it with u, and then we go back to x, we might miss the fact that we actually crossed a boundary that's illegal, immoral, and wrong. Because by the time we get it back here, we might not recognize it when we did the integral here. So you're better off using u for that reason. You're also better off using u because u is easier, usually. Now, real AP calculus talk. They don't care. They're going to give you a problem that don't have weird bounds in the middle. So if you choose to do one way or the other way, I don't care. You don't care. Everybody's happy. Okay? My suggestion is you switch to using u.
But that's only when you have bounds.
When you have bounds. When you don't have bounds, you have to go back to x because you have to write down the answer the way it should be written, right? You can't have u to begin with. But if I'm just looking for a number, switch your u bounds. Okay? Does that make sense? All right, let's see how well we did. Go ahead and try try problem number 73.
Mr. Izzy,
Yeah.
in that last problem, where did the 1/2 come from?
Well, when I needed to make a 2, right? I didn't have a 2.
Oh.
So I put this 2 in. When I put the 2 in,
Yeah.
I need to put a 1/2 out in front to fix it.
Gotcha.
All right? Everybody try 73, see how we do. Take a look at this problem. I'm going to set u equal to the x cubed plus 1, if nothing else is because that's what's in the parentheses. U equals 3x squared dx. Sorry, du equals that. So then I move this over here and I recognize what I've got. I've got a 1 to 2. I've got a x cubed plus 1 to the 1/2. Everything else is in front of that dx squared, right? So that dx. I look at that and go, well, I'm actually closer than I thought I was. I need to get rid of a 2 and I need to make a 3. So what I would traditionally do is do 3/2, which means I got to put a 2/3 out in front. Does that make sense? Because I want the 2's to cancel out and I want to make a 3. When I do that, I have to put the flippy out in front. Ironically, how well you do this part doesn't matter. It's that the one that matters, right? This is going to go away.
Oh, true.
2/3 integral x cubed plus 1 to the 1/2. This becomes 3x squared dx. Am I ready to U it? Cleary, how are we doing? Look at your head. Just had something bad happen in there. What? You good? No. Okay. So this is du, right? So because that du. So I replace that with du. That's u. That's u to the 1/2. This is 2/3. Now, how do I fix my bounds, Miss Kirkland? How do I fix my bounds?
Is you take the 2 and the 1 and you plug it into
I'm plugging 1 in, and I get 1 cubed plus 1, which should be 2. And then I'm going to put in a 2, and 2 cubed would be 8, plus 1 would be 9. So those are good? Raises power by 1. Divide by the power you get. Larry, you looked down at a pivotal moment. That was a huge moment. With me? Okay. 4/9. Plug in my 9. 9 to the 3/2 minus 4/9. 2 to the 3/2. Square root of 9 is 3. Cubed would be 27. Divided by 9, that's 12. And this is 8/9 root 2. I'm done. Do you? You have the whole back's blank, so go ahead and write the problems in the back, and then you can do it. Totally happy with that. All right, try some more.